In this example, we have to consider this network given over here and answer all the following questions. The first question is, we need to determine the mathematical expression for the transient behavior of VC, IC and VR if the switch is closed at t equals to 0 second. That is, when the switch will be closed, we need to determine the expressions, that is the equations for VR, IC and VC. After that, we have to draw the curve of VC versus time, VR and IC against time. After that, we have to find or determine the value of VC at t is equals to 20 milliseconds. The next question is, on a practical basis, how much time will be passed before we can assume that the charging phase has passed? We also need to determine the total charge on the plates. And after that, there is a question which says, if the capacitor has a leakage resistance of 10,000 mega ohm, what is the initial leakage current? Once the capacitor is separated from the circuit, how long will it take to totally discharge, assuming a linear, unchanging discharge rate? In order to determine the expression for VC, IC and VR, at first we need to determine the time constant tau. Tau is equals to RC. For this particular circuit, R is equals to 8K and C is equals to 4 microfarad. Hence, tau will be equal to 32 milliseconds. The generalized expression for VC equals E times 1 minus e to the power minus t by tau. For this circuit, E is equals to 40 volts. Hence, the expression for VC will be equal to 40 times 1 minus e to the power minus t by 32 milliseconds. IC equals E by R, e to the power minus t by tau. If we substitute the value of E and R in this expression, then IC will be equal to 5 milliampere e to the power minus t by 32 milliseconds. VR equals E times e to the power minus t by tau. In this expression, if we substitute the value of E, then VR will be equal to 40 V e to the power minus t by 32 milliseconds. Now, if we plot the graph of VC against time, this is how the graph will look like. We know that when t is equals to 0, the voltage across the capacitor will be 0 volts. And when t is equals to 5 tau, the voltage across the capacitor will be almost equal to the supply voltage. When t is equals to 1 tau, the voltage across the capacitor will be 63.2% of the supply voltage. By substituting these values, we can sketch the generalized shape of the graph of VC versus time. The graph for IC against t and VR against t will look like this. Substitute the value of t equals 1 tau and t equals 2 tau, t equals 3 tau in the expression for IC, and these are the values that you will get. Plot these values and this is the graph that you will obtain. The same thing goes for VR. The shape of the curve of IC and the shape of the curve for VR is the same because initially, as I have mentioned in the previous slides, that as soon as the switch is closed, the current will rise and then it will exponentially decrease. The same goes for the voltage across the resistor. Initially, it will be maximum as soon as the switch is closed and then it will exponentially decrease. The next question was to determine the value of the voltage across the plates of a capacitor when t was equals to 20 milliseconds. So if we substitute the value of t in the expression for VC, so if we substitute the value of t in the given expression for VC, which is 40 volts 1 minus e to the power minus 20 by 32, then this is the answer which you will get, that is 18.6 volt. So the voltage across the capacitor at time t is equals to 20 millisecond is 18.6 millivolt. Now, the next question was to determine the time that it will take for the capacitor to be fully charged. We know that for a capacitor to be fully charged, it usually takes 5 tau time period. We know tau is equals to 32 milliseconds. Therefore, 5 times 32 will be 160 milliseconds or 0.16 second. After that, the question asked to determine the charge which was deposited on the plates of the capacitor. Q equals CV. C is equals to 4 microfarad and the voltage across the capacitor at full potential is 40 volts. Hence, Q will be equal to 160 microcoulomb. After that, it was said that if the capacitor has a leakage resistance of 10,000 mega ohm, then what will be the leakage current and how long will it take for the current or for the capacitor to be completely discharged? Well, we know according to Ohm's law that I is equals to V by R. Hence, the leakage current will be 4 nanoampere. The equation for I can also be determined using the formula I equals Q by T. We know Q equals 160 microcoulomb and the leakage current is 4 nanoampere. Hence, T will be equals to 11.11 R. That is, if the capacitor is after being fully charged, if the capacitor is removed from the circuit and kept at a place, then due to the leakage current, it will take the capacitor 11.11 hours to be completely discharged.